We are now on to problem 31. We have a orbiting particle with a radius r, a mass m. So a particle of mass m moves counterclockwise around a horizontal circle of radius r, as shown above. The angular speed of the particle is given as a function of time t by omega of t equals bt, where b is a positive constant and t is greater than or equal to 0. Okay, so which of the following best describes the acceleration vector for the particle at the moment shown in the diagram? Let's go through all the possibilities and talk about why they could or could not be correct. A, it is directed towards the left. Now, if we look, one might initially think that there is no acceleration towards the left because it just has an omega, but it actually has omega as a function of time with a positive constant, meaning that it's getting greater, so it is accelerating in the direction that it already has angular velocity. Well, it is angularly accelerating in the direction that it already has angular speed. So it actually does move towards the left because the particle, or it does have an acceleration towards the left because the particle has an angular velocity towards the left, and that angular velocity rises as a function of time, with b as the constant, the linear function of time, and so that gives it a acceleration to the left for time is greater than or equal to 0. So it does have an acceleration towards the left, so A is a possibility. Let's go on. For B, it is directed towards the bottom of the page. Okay, so since we do have a mass orbiting with a radius in a circle, it does have a centripetal acceleration, meaning that since it is currently at the top of the circle, its centripetal acceleration would be pointing down towards the bottom of the page, so it does in fact have an acceleration pointing to the directed towards the bottom of the page. So that is also true, which means that both A and B cannot be true because they're both true, but they don't include the other. C, it is directed toward the top of the page. No, that doesn't make any sense at all. There's no sort of acceleration that would cause the particle to go up. D, it has components directed toward the right and toward the bottom of the page. That is not correct. It does have a component directed toward the bottom of the page currently, and when it is on the bottom of the circle, it will have a component directed towards the right, but at that point, the component that was initially pointed down, the centripetal acceleration, would still be pointed towards the center of the circle, which means at that point it would be pointed up. So D does not work. And E, it has components directed toward the left and toward the bottom of the page. Now we have determined that there is an acceleration both towards the left and towards the bottom of the page, so this makes sense. So yeah, the answer is E, because it has an angular velocity to the left with a positive constant as a function of time, which is greater than or equal to 0, meaning it has an acceleration in the same direction as that angular velocity, meaning it has an acceleration towards the left. And since it has a centripetal acceleration towards the center of the circle, it's at the top of the circle, that makes the arrow currently pointing down towards the bottom of the page. So those are the two components of acceleration that this mass has.